Hi guys, fourth and final video on describing distributions. When you're presented a data set and you need to describe a distribution, the first thing you're going to do is you need to make some sort of graphical display, whether it's a stem and leaf plot, histogram, dot plot, box and whisker plot, whatever. The next thing you're going to do is you're actually going to write a few short sentences about what you see in that graphical display. So in this video series, we've talked about shape and how to do that. We've talked about outliers, center, and now on this video, we're going to talk about spread. So we're just going to talk about what things can you talk about with spread depending on the type of graph you get. So starting out, stem and leaf plot, yeah. Stem and leaf plot, here we have it. We can see all the data points. So there's a few different options you can do with spread, few different options. Probably early on in a statistics course, the most basic way to talk about spread, or just how spread out data is it compact together, is it spread out? That's what we're talking about with spread, but there's some technical ways to label that. You aren't going to just say, oh, it's super spread out or it's super condensed. So ways we can talk about spread with a stem and leaf plot is you could do the range. We can do the range here because we have these specific values. When you do the range, what you're going to do is you're going to take your largest value minus your smallest value. So our largest being 65, if this is a tens and a ones digit, the smallest being 12. So we could take 65 minus 12 and say the range of this random data set is 53. Other options is, since we have all the specific data values, we actually know every single point in our data set. Other things you could do is you could talk about standard deviation. So that is another option. But remember, you can only do standard deviation if you have the specific values, okay? The next type of graph we're going to talk about is histograms. Now, depending on the type of histogram you have, it's going to kind of limit your options here a little bit. So I'm going to do a histogram where I kind of know the specific values, and a histogram where I don't know the specific values. So in this left one, the reason I know the specific values is the classes are of size 1. This is a class of 10, 11, 12, 13, 14, 15, and then our frequencies. So when I look at this histogram, I know I have one data point that is 10. And yes, this is a very lazy drawn graph, but I know there's 2 data points that are 11. So I know I got a 10, I got an 11 and an 11. My 12 looks like it goes up to 4. You get the idea, right? So with this specific histogram, it takes a little bit of work, but because of the class sizes, I'm actually able to figure out specific data points. Okay, so if I have specific data points, it's very easy to go and do the range, which again is the largest value minus the smallest value. So 15 minus 10, which is 5. So I could say the range is 5. Other options is, if I know how to do it, I could do a standard deviation, because remember, again, you could do a standard deviation if you have all the specific data points and you understand how to do a standard deviation and what it means. The other type of histogram here I want to talk about is when our classes are not a size 1. So what I mean is this piece of the histogram here represents all data points from 10 to 14. So in here, I don't know if these data points are 10s, 11s, 12s, 13s, 14s. I don't know which one they are. So it's hard for me to identify set or single data values. Same over here with the 15 to 19. You could count up how many data points are in the 15 to 19 range, but I don't know, are those 15s, 16s, 17s, 18s, or 19s? So I don't know specific values. So when we talk about range with one of these, a spread with one of these, it's a little bit tougher and our options are limited. All we can do is range, highest value minus lowest value. But again, you're stuck with that issue of, I don't know specific values. I don't know if my largest data point is a 25, a 26, a 27, a 28, or a 29. I don't know which one it is. And I don't know my low end of 10 to 14. So what we do is we play it safe here. We do what could possibly be the largest data point, and what could possibly be the lowest data point, because we want to get our range right. I would hate to say, the range is 10, and then you come find out later on it's 14, and things are much more spread out than they are. You'd rather be very conservative, say, things are about this spread out, but if I don't, it's a little bit tighter. So we're going to take the largest data points. The largest possible we could be is 29. The lowest we could possibly be is 10. So you would take 29 minus 10 for a conservative estimate and say, the range is 19. Next type of graphical display, a dot plot, which we can go pretty quickly through this one. Dot plots, you are going to know the specific data values. I know there's 1, 1, 2, 2s, whole bunch of 3s, couple of 4s, couple of 5s. So when I know specific data values, we can always get away with range here. We know our largest data point, we know our smallest. But since we know specific values, you could also do a standard deviation as well. So either or would work as describing the spread here. And then finally, we have a box and whisker plot. So box and whisker plot is going to add a little bit new feature here. So we could still do range. You still will be able to figure out your highest data point, 30 something, lowest data point is 10, and subtract those. You could still totally do that. So range is one thing that's common throughout all of these. Could always take high minus low no matter what. Things we can't do, though, is we cannot do standard deviation. Because like I've talked before, with a box and whisker plot, we don't know the specific data points. I know there is a data point 1 at looks like 32. That's about all I know. Okay, the rest of these data points, it's hard to know exactly what they all are. I know 25% of my data is in here, but I don't know, A, how many data points they are, and B, I don't know what they are. So with box and whisker plots, you never really know how many data points there are or how many. You just know percentages, 25% here, 25% here, 25% here, so on and so forth. So we cannot do a standard deviation. One thing we can do, though, with a box and whisker plot is the interquartile range. Okay, it is a type of range. What it's going to do, it's going to take your Q3, which is the top end of the box, and you're going to subtract Q1. So take the value of Q3, which in this case is, we'll just say 20. The bottom of the box we'll say is 13. You take 20 minus 13, and your interquartile range is 7. So you do get an additional option there with a box and whisker plot. So again, that is describing spread, and that concludes how you can describe a distribution. Make a graphical display, and then go through shape, outliers, center, and spread, and you'll be good to go. Bye now.